All right, so welcome back, everyone. Today we're going to be starting chapter 2. We're going to be looking at relations and functions. Honestly, functions are really a lot of the core of what we do in Algebra 2. A lot of what we'll be doing this year is looking at different types of functions and kind of seeing how they work or how we can do different things with them. So this is something that won't go away, but we're going to just kind of start with the basics. You probably have talked about relations and functions in an Algebra 1, but I'm sure it's a little bit fuzzy given how the last year of school has been, and it's been a while since you've been in Algebra 1 anyways. So a relation in terms of a math class, it's a set of pair of input and output values, and there's different ways you can write it. You've probably seen these throughout your mathematical career or your courses you've taken. The first way is a table. So if you have an XY table, I'm sure you've seen these before. Ordered pairs, so we could just kind of write each one of these rows as an ordered pair or a point, but like the fancier way to say it's an ordered pair, but a lot of times we just call these points, right? So if we just write these one by one, that's how we would change this table to our ordered pairs. Okay, the third way we can represent a relation is called a map-in, and this is kind of the weird one of the group, but it's like where you have these two ovals. The first oval is like your X values or your inputs. The second oval is your Y values or your outputs. So just one thing to be careful when you're doing this, your first oval is your X values. So when you start writing these down, you have -3, you have +3, and you have 4. If you have a number that repeats, for example, we have 2 4s, you just put it one time. Don't repeat yourself when you're making a map-in. And then we do the same for our Y values. So we're looking at our Y values. So if we'll write those in, we got 4, we got -1. Like I said, I'm only going to put it one time. And then we got a 3. And then with the map-in, you want to kind of connect the numbers that go together. Like -3 goes to 4, 3 goes to -1, 4 goes to -1, 4 goes to 3. Just kind of like how they're connected basically here. The last way we can represent a relation is with a graph. So I'm just going to plot these ordered pairs or these points we have. So we have -3, 4. That would be approximately there. We have 3, -1, go right 3, down 1. That would be there. 4, -1 would be 4 to the right, down 1. That'd be right next to that point we just did. And then 4, 3 would be over here. And you're not going to connect these points because these are unique points, how they're written in this table, but sometimes you will connect points for different types of functions. So that's a relation in different ways we can write it, but in a lot of times what we're interested in is a special type of relation, which is called a function. So a function is a relation in which each element of the domain corresponds with exactly one element in the range. So it's really a fancy way of saying, I like to think of a vending machine. So let's say you go to the pop machine every day, you put in your code A3, it gives you a Sprite every day. Let's say it's like one of those button ones like with food. I know a lot of pop machines you click the picture, but let's say it has like a combo. So you type in A3, you get your Sprite every day. Let's say you come in one day, you're just not looking, you type in your A3, here pops out a Coke. You're probably going to be kind of annoyed, I mean, unless you like both, but we would say that machine's not functioning. The idea is every time you put something into a function, it should do the same thing. If you're putting in an input or a command, or you're pushing a button and it starts doing something wonky all of a sudden, we're going to say it's not functioning. It's not a function. So a function basically, if you put something in, it's always going to give you the same thing out. So like I said, we're going to look at different types of relations and just see if we can tell if they're functions or not. So concept one here, we're going to look if a set of points is a function. This is similar to the second section you're going to see in your Delta Math. It's called determine if a set of points is a function. But all you want to do is you want to look at remember your X values are your inputs. You don't have to write this, but anytime I use inputs, I'm really talking about X values. And when we talk about outputs, that's talking about Y values. So just in case I use these words interchangeably. But to see if this is a function, you want to look at all of your X values. And you want to see, do any of your X values repeat? So in this first example, notice I have a 4 and I have a 4 here. So I have the same input. Look at what happens. I plug in this 4, I get -1. I plug in this 4, I get 1. That's two different things. I'm putting in an input, it's giving me two outputs. It would be like the vending machine. If you type in a code 4, it gives you Skittles one day. You type in the code 4, it gives you Doritos. You might be annoyed, I mean, unless you're just not a picky person, but it's not functioning. It's not working like it should, right? If you put in a command, it should work the same. So this would not be a function. So I'm just going to put not a function. But how about you look at this second one? Would this one be a function? So look at your inputs, see if any of them repeat, see if it kind of meets the requirements of a vending machine. All right, so if you give it a look, if you look at your x value, you see you have -7, you have 9, you have 14, you have 7. All of these are unique, like they're all different. So that means none of them are repeating and doing different things. So this is okay. And you might have noticed, maybe you kind of observed, you might have saw, hey, Swope, I see that there's a 14 and a 14 here for my y values. That's okay. You can have different inputs give you the same result. It's like with the computer. I can press the power button here to turn off my computer, or I can go down and I can click the button that says shut down. They're different. Sometimes there's more than one way to get the same result. That's okay. That doesn't mean it's not working. Even with a vending machine, there might be more than one row that has the same product in it. So it's really the fact that you're only interested in the inputs when you're telling if something is a function. So this one here would be a function. Okay, and now let's move to the back of our sheet. How to tell if a mapping is a function. So like I said, we want to look at our x values, our inputs. So for this first one, I want to just kind of look at each one of my numbers. I just want to see, do any of my inputs go to more than one thing? In this case, 2 just goes to 6, 3 just goes to 6, 4 just goes to 5, 7 just goes to 8. So none of the inputs are doing multiple things. So that's good. It's a function. It's okay that you have two things going to 6. Like I said, I mean, there's a lot of times there's more than one way to get the same result when you're working with computers or you're working with something. That's okay. The problem is if you're putting in a code or you're putting in a command or you're pushing a button and it starts doing two different things. Let's look at the second one. So this one's not a function. Maybe take a second to look why it isn't. But if you notice, you should see this 0. See how this 0 goes to -3 and it goes to 7? That's a problem. It's like if you're pressing a button, it does this. It does -3 one time. You press this button, it does 7 one time. Like that's not okay. That's not a good thing. If you're pushing a button, it starts doing different things. That's not a functional machine. And then the last concept we're going to look at is how to tell if a graph is a function. So a vertical, there's something called a vertical line test, but basically it states that if a vertical line passes through more than one point on a graph, the relation then the relation is not a function. And just keep in mind, remember, vertical lines go up and down, like your vertical is how far you can jump. But you want to just kind of visualize in your head, if I draw vertical lines, is there anywhere that hits the graph in more than one spot? So like 2 or more spots. So like, for example, this first graph, it hits here and here with this vertical line. So that's not a function. It hits 2 places. So I'm just going to put not for not a function. Or here, I'm actually just going to put NF for it's not a function. This one here, I basically have a line. Anywhere I draw a vertical line, it's only going to hit one spot, right? Like there's no vertical line I could draw that hits more than one spot. So this one would be a function. What about this next one, this V-shaped graph? What would this one be? Is this a function? So if you draw vertical lines, you should see it only hits in one spot. Like no matter where you put a vertical line, like kind of imagine you're putting an infinite amount of just like vertical lines everywhere. Anywhere you put one, it's only going to hit one spot. So this would be a function. And then anytime you see a circle, it's kind of a dead giveaway. If you see a circle, it's going to hit 2 spots. So that's not a function.